What's up, Notjust developers? Welcome back to another tutorial. And today in this video, we're gonna continue our Amazon price tracker application using React Native, Supabase, and BrightData. So very excited about this project because it's such an amazing use case for using data and for building this application. And the way I came up with this idea is browsing some products and trying to always refresh a page on Amazon to see if the price changed. And then I actually saw that Amazon products, some of them can change their price up to 8 times in a single day. And I thought maybe that's an application idea that we can build together where we could get information from Amazon, and maybe in future we can even get it from other e-commerce websites as well, so that we can compare and find the cheapest products. We can also fetch this price multiple times in a single day or throughout a week to find when it was the lowest in price, and also to subscribe to price alerts. So the tech stack for this application is obviously React Native Expo and Expo router for the mobile application. For the backend, we are using Supabase that offers us authentication, storage, database, API, edge functions. And the data, how do we get the data? Well, there is no Amazon price API, so that's why we have to scrape this data. But instead of manually having to build a scraper and having to host this scraper and maintain it whenever Amazon changes things, what we are actually doing is we are using BrightData and their web data API. BrightData is the sponsor of this series. Thank you very much, BrightData, for making this so much easier than it would have been if I had to build the scraper myself. Because I've been working with scrapers in the past, and it's a pain because most of the times it works initially, and after a couple of tries, you get through CAPTCHAs and you are being blocked by the websites because sites like Amazon don't really like being scraped. And they can detect it really easily if you're running it from the same machine by simply looking at the IP and how many requests you're making. With BrightData, the scraping is done from a global database of proxies, over 78 million proxies, so that your data is always there. You can always get it from the actual source. So let's have a look at what we already have. This is the part 2 of the video, and if you want to follow along in the part 1, make sure to follow the link in the description below, or if you're interested, you can grab the source code. I'm also going to leave a GitHub repository there so that you can start from this point and follow the exactly features that we're going to build today. But before that, let's have a look at what we already have and what we managed to build in the previous video. So this is our application. First of all, we see the searches that we have done in the past. For example, if I'm going to look at this MacBook M3, we're going to see multiple MacBooks that were scraped from Amazon and their prices. If we press on them, we are going to open it right on Amazon. And today, what I want to do is also to be able to watch these searches so that we can see price history, which we don't have yet. We can search for something new, for example, an iPad Pro. Let's do that search. We're going to see that it's a new search, and we can start the scraping job. The data is not updated in real time, so I have to, in the application, I mean the scraping job already started. So I usually have to go back and reload the application, and we're going to see the iPad Pro search. I can go there, we see that it's scraping. And behind the scenes, what's happening is we are invoking the web scraper API from BrightData, which is an API that makes the scraping part very abstract. Like, we don't have to worry about that. We are interacting as you would interact with an API. You are sending a request. BrightData has a lot of these pre-built APIs, and they are maintaining it for you. Basically, they're promising you that the data that you need will always be there, and they will update the scrapers to make sure that everything is up to date. And here in the Amazon Products API, we see that by simply sending the keyword and the URL, the domain that we want to scrape, we're gonna get a lot of data in this format, like the URL, the name, the initial price, final price, and so on. And in the dictionary, you can actually see all the data that you get. So it's a lot of things that you have access to. And this data is actually scraped in real time. That's why it's taking usually around, here it says 1 second. For me, it was around from 9 seconds or even less up to 30 seconds. Usually that's how it's happening. And if I go back into my application and reload it, we should have this data here in our application. It says that it's still scraping, but I see that it's ready. So maybe my backend is not receiving this data, but let's check it. Oh, come on. So where is my diagram? So from the backend perspective, like how everything is happening is from our application, when we start a scraping job, what we are actually doing is we are invoking an edge function on Supabase. And that edge function basically is building a request or is interacting with BrightData, with a web API. So we are interacting from edge function. We are starting a scraping job with web scraper. BrightData then behind the scenes is invoking a scraper, which actually goes ahead, loads Amazon web page, scrapes the data, and then it will return it back. The way it gives the data back is we're gonna tell BrightData like where to deliver the information. And the information is going to be delivered in a separate edge function. Basically, BrightData is going to invoke this edge function, and from here we're gonna store the data in the database so that we can work with a cache, so that the next time we go here, for example, in the iPad Pro, I'm not sure why I don't have data here yet, but if I look at our pages, we're gonna get this data already from our database. And everything we managed to build previous time, we have here tables, for example, searches, which are different searches that are performed by users, products, which represents products at a point in time, or products information as they were during the last scrape, and product search. This is a relationship between a search and a product, many-to-many relationship. So here we have it, and yeah, that's what we are working with. The plan for today is I would like to subscribe for real-time data updates, because whenever I press start scraping, I don't want to reload the application to have a data. I want these changes that are happening on the database to be reflected on the front end automatically. I want to also automatically trigger a scraping job. So basically I'm improving on what we already have. Instead of pressing like the start scraping button, okay, here is the iPad information. Instead of doing that, what I would like to do is whenever we create a search, I want automatically to trigger the job. I want to add price history to be able to track and visualize how the price has changed for a specific product. I want to add the possibility for users to track searches. So basically to mark like, hey, I want to watch this iPad Pro, and if there is any updates, send me a notification. I want to know, I want to get alerts if prices dropped. So that are the plan for today. If you're ready, I think we can get started. Hello, everyone who is joining us live. How are you doing, guys, today? Hello, Brian. Hello, Julio. Hello, Mohammed, Binay, and Rogelio. How are you doing, guys? So let me make it smaller like this. Here is the application. The source code is available following the link in the description, and you should have this setup. In our application, we have here in the application folder, we have our bottom tabs, and in the index, we have our search history. Then on tab 2, we don't have anything yet. And then we have this search/ID, which is displaying one specific search. AKA is saying, hey, I've done modern HTML and CSS. Can I make this with you? I don't know Supabase. This is a little bit more advanced. Like, I'm pretty sure you're going to be able to follow it along because I always try to make it as easy as possible. But what I would encourage you to follow, if this is the first time you're using Supabase, is going to be the video from our homepage if you go to our channel. So if you go to our channel, under videos, we should have this React Native full 8-hour course. So it's on Expo, Expo Router, and Supabase. And that one is very beginner friendly. It's a lot of documentation, so it's going to be better if this is the first time you are building React Native and Expo and Supabase applications. But feel free to watch this video and follow it along to see if you can implement this, because it's a really fun project to build. So what do we start with? To subscribe to real-time updates, right? To subscribe to real-time updates. Let's go ahead and look at Supabase real-time. And real-time is going to send and receive messages to connected clients. So we have to first enable it. Yeah, let's go ahead and enable them. Let's go to our Supabase project on supabase.com. Here under databases, we're going to go under the publications, and here we have Supabase real-time. And this Supabase real-time is going to notify us about insert, update, delete, and truncate based on 0 tables. If I'm going to open it up, I think we're going to enable it on the searches, so we can watch a search. If the status of a search will change, we're going to do something. So now that means that if I go back to publications, we're going to see Supabase real-time for one table for these operations. Now, this is the name of the channel that we need to listen to. So if we look into the documentation to listen to, we're going to call this supabase.channel.on and subscribe. Where do we do that? We're going to do that on the search details page when we go to a specific search. So here in use effect, let's go ahead and register and start listening to changes. Let's do that. So the channel is going to be the name of our publication, Supabase real-time in this case. On Postgres changes, event insert, schema public, table to-dos, handle inserts. I think I'm going to change the event to update. So when we update the schema public and the table, how's it called table? Searches, I think. Searches. We want to do handle inserts, or we want to let's extract this information like Supabase, like the fetches, like querying the search and the product into a separate function called const fetch search and product. We can call the fetch search and products in the use effect. And I'm also going to call it when we receive this update. Or maybe no, maybe in the handle inserts, we are also going to get some information. We can define it here. Payload. I just want to see what's in the payload. Console log. So updated payload. Let's open it up. And I'm going to go ahead in our database and manually I'm going to do some changes to some of these items. I don't know why my internet today is not one of the best. So under searches, let me change, I don't know, iPhone 10 here and do save. If I look here, it doesn't like something. I don't know exactly what it doesn't like, but I'm gonna reload just to make sure. And I'm gonna do it again. 11, do a change. Oh, I need to go on that page. Yeah, sorry. So I went on that page. And now if I'm going to do an update, we see updated. And the data that we get is what? When it was committed, we see event type update. We see the new record. And also we should see probably the old record, right? And the old one with only the ID. So because we already have a new record, maybe you can even take it and set it in state. If we specify here event update, does it make sense to check if payload dot event type is equal to update? Or that's obvious? I think that might be obvious. So what I'm going to do is I'm going to simply set search with the payload dot new, with a new value of our payload. So now if I'm going to go here, I don't know what, we need to check if it's actually this item that was updated. So we can check if payload.new.id is equal to this ID only when updated, because it might be another object that was updated. Maybe here you can even do question mark. So now this is iPad Pro. If I'm gonna find it here and change to iPad Pro 11, if I come back here without any change, I'm expecting it to update automatically. Let me look here. It didn't, right? Let's see. Reload. Let's go here. iPad Pro 11. Let's remove 11. Save and come back. And it's nothing. Come on. I think it's payload.new. Console log. Let's do a JSON.stringify. Payload new, null, and 2 to see what data do we receive in the update. So I'm going to do here 12, save, and check here, it's ID 16. I think the problem, you know what's the problem? Is that this ID is a string. Yes, this ID is a string. I'm not sure why it works here. But we need to probably either use only two equal signs, like equal sign, or three of them, but in this case, maybe do number, or maybe parse int, like this. So now if it's going to be 1, 2, 3, 4, save, it's automatically updated here to 1, 2, 3, 4. But if something else is updated, for example, Samsung Galaxy S20, and I rename it to Galaxy, it's not going to be updated here because we check if the update is for this item or not. And it's going to help us when our status is going to change, for example, from new to scraping, is going to automatically change here. And then if I do here done, by the time I come back, like it's automatically updated. So now we are listening to these updates here. Because today I hope to have a little bit more time, I'm going to try to be a little bit more mindful about types and try to fix some of the TypeScript issues. For example, in this case, the ID can also be an array of strings. And to fix it, I'm going to go to use local slash parameters, and I'm going to tell it that, hey, the parameters will only be an ID of type string. Now it should not worry about it here. Not sure why ESLint radix, probably it wants 10 here. The base, we want to parse it in, which 10 is kind of obvious. I don't know why we need to specify it like that. Set search, it doesn't know what payload can be because we never specified it. Maybe we're gonna specify Supabase types a bit later. Let me check if we return anything from this .subscribe. Because whenever we are subscribing, we also have to unsubscribe. So let's do const subscription equal to this thing. And the subscription is real-time channel. What can we do with it? Let's try to return a function. And whenever you return a function from a use effect, this function is going to be called whenever we are cleaning this use effect. So let's try to call subscription dot unsubscribe, and that's probably what we need. Unsubscribe like this. And you don't need like a body for this function. You can simplify it like this. Always remember to unsubscribe whenever you're subscribing to something, because whenever I come back and go to something else, like it should subscribe, it should create a new subscription. And whenever this changes, I update the search, but I also want to start refetching the products because the products most probably have changed. So here I'm going to split this function into two things. I'm going to create a function fetch products that is going to have like these product queries. In the use effect, make sure to call this fetch products. Let's rename this to fetch search, not to be misleading. And let's call fetch products whenever the payload changes. Because if the payload changes, most probably, not always, but in some cases, the products have also changed. For example, if the status has changed. Maybe you can even test that if the status changed or not, but I'm going to simply call the function fetch products. Now I believe if we're gonna start a new fetch, for example, let's do Nike Air Max. And if I'm gonna do search, it's going to be new without any change. I hope in a second it's going to be scraping. Or not. This is a promise. I think we need to put it in a function like this. Why it's not updated there automatically? It's still new. It's still new. And on BrightData, we didn't trigger this BrightData. Oh yes, because we never pressed start scraping. This is going to be our next step to automatically start a scraping job for a new search. But now if I press start scraping, it will automatically trigger the function. That function is going to change this one to scraping, and we get this information automatically without us having to do anything. Now this is running on the scraping job is running on BrightData. It should take a couple of seconds, and after that you see it's ready. If I go back without any change, the information is already here. So this is cool. This is now working much better. Like, we don't have to reload the application to get the new updates. It's going to happen automatically. While I'm still here, I don't really like how the images are displayed here. So I'm going to go into the components, into the, where is that? Application search. And here we have an image, and I will do resize mode contain. Okay, now it's better, as you can see. Doesn't scroll all the way till the end, but maybe we can fix it a bit later. Okay, so now we have some subscriptions to get some data. So I can go ahead and do git add, git commit -m, real-time subscription for search updates. Hello, Sintayo. Okay, the next one that I want to fix right now is going to be the automatically triggering a scraping job. Because even me, like as a developer, I know how this application is working at the moment. Whenever I created a new, like, I don't know, let's say LG TV, a new search, I was expecting it to automatically start scraping, but I had to manually come here and press this button. What I want to do is I want to, as you can see here, the thing that is starting a scraping job is our edge function here, start scraping. And the way it works at the moment is manually by pressing on this button. I can show you by going here in the application search ID, and we should have here start scraping, which is invoking the scrape start function with our record. So basically we are manually, on a button press, we are invoking this function. What if we can automatically invoke start scrape for every new search item in the database? So that's what we are trying to do. We want to tell Supabase, hey, whenever we get a new item in the database for the search, go ahead and invoke this function without us having to manually do that. And with Supabase, and because it's built on Postgres, this is really powerful and not that complicated to do. If I just remember how I did it, we're gonna go to databases, we're gonna go to the webhooks, and here database webhooks can be used to trigger serverless function or send request to an HTTP endpoint. So database webhooks, see, can be used to trigger serverless functions. This is the serverless function, start scraping. Let's go ahead and enable the webhooks on our database platform webhooks. Let's enable it. And let's create a new hook. The name is going to be start scraping for new searches. Not sure if this is a very good name, but we're gonna go with it. When do we want to fire it? We're gonna fire it when I'm gonna scroll down to see find public searches table, and the event we want to fire it at is the insert, when an insert is happening. What do we want to do? We can either invoke an HTTP, send an HTTP request, for example, invoke, send it to some webhooks, or we can invoke a Supabase edge function. The edge function, the method is going to be post. Here you can select what method to invoke. I'm going to invoke scrape start. And the time allowed is how much you will wait until you consider that something is not working. So 1000 is okay because we are not waiting for the scraping to finish. We are just starting it and that's it. HTTP headers. Do we need any HTTP headers? I think we're gonna need it because whenever we invoke the scrape start, we need the authorization. So let's go add, let's press on this button, and here we can add auth header with service key. Required if your edge functions enforces JWT authentication. I think we're gonna do this one, and it should automatically add this key that is your authentication token, your anonymous token. What else? I think that should be it. You can also add some parameters if you want, but let's try to create this webhook. So what it's going to do whenever we insert a search item is going to invoke this function, which is our edge function here, scrape start. In the scrape start, I'm going to actually go ahead and do a console log just to see what data do we receive. So in the function scrape start index, in the Dino serve, let's go ahead and do const data equal to this, maybe not data, but request JSON is equal to this, and let's do a console log. Console log. Let's do a JSON.stringify of this request.json so that we can properly debug and see what's happening there. Now I'm gonna go ahead and do npx Supabase functions deploy. I need to have my Docker running for the local Docker. I think it's this one. Hello team, how are you doing? And let's go ahead and try again npx Supabase functions deploy. Will it deploy it to here? Last updated at it's 1 week ago. And if everything is okay and I will reload, I should see last update here for this edge function. You need additional permissions. Scrape start is for October. So now I'm going to go here in the logs and I'm going to start a new search. The search is going to be, what are we going to search for? I don't know, air fryer. Air fryer. It's new, and I hope that this new item inserted in the database invoked our function. Maybe it didn't, maybe it did. Let's see. If I go to invocations, we're gonna see that just now, no, it actually didn't invoke it, right? Okay, it did. It's okay. So what do we see? We have an error because we are trying 2 times to consume the body, but we have here some data, the log that we are console logging to know like what information we got. So look at this. This is our function being invoked by the database whenever we insert a new item. So we simply inserted a new item in the database and the database invoked the edge function, and this is the data that it sent. It sent the type insert, it sent the table searches, and it sent the record with the data that we inserted, air fryer here with status new. That's exactly what we need in this function, because I already knew that we're gonna have this record. So that's why we are destructuring the record from request.json. And now I simply have to remove the first 2 lines that I used to log, and I will go ahead and redeploy it. And everything will work as it was working when we pressed the button, because the record is what database is sending, and the record is what we are getting here from the body and using to start scraping here, start scraping on BrightData. So let's go ahead, and after this deploy has finished, let's go back. Let's maybe reload the application. And let's search for iPhone. Which one was launched? 16. Let's try to search. Do we have anything? Without me doing anything, I see that the status has changed to scraping. And in a couple of seconds, maybe 10-15 seconds, we should see automatically here products filled in after BrightData has finished scraping this data. Done. Look at this without me doing anything. Oh my God, that's so amazing. So at this moment, we are safe to maybe even remove the start scraping button, but maybe we can leave it because we can press start scraping and it will do it again. Maybe you come back here next day and you want to manually scrape. It's going to do that. And sometimes it's going to find like new items. In a couple of seconds, it's going to go the status from scraping to done. Done. Here it is. And we can start buying it. Perfect. Mikhail, thank you very much for the nice words. Thank you. Okie dokie. So now we are automatically triggering a scraping job. Amazing. You know what I'm thinking? Maybe we should also trigger the scraping when we update a search. Because what if I'm already thinking ahead of time, because let's say later on we are going to implement this functionality of automatically scraping some searches at specific intervals of time. Like if you're watching a search, you want to run this job every single hour or every single day. So we're going to have a function that will collect all the searches that are watched, and maybe that job is only going to switch the status from done to waiting to be scraped. And if that status has changed, we're going to trigger the functions again. Should we? Or maybe not. Maybe we are actually going to invoke it, because the updates on that table are going to happen maybe often, and maybe we don't want to trigger that function over and over again. So yeah, let's leave it like this right now, so that we start scraping only when we create a new search in our database, and then we have to manually invoke that function by pressing start scraping, for example, or later on intervals of time. Done. So now it has a lot of items, duplicated items probably, right? Yeah. I'm gonna add that to okie dokie. What next should we integrate? Usability. Thank you very much. Yeah, everything is well. Thank you. How are you doing? Look, our next job is the price history. Before we go there, let me actually adjust some of the stuff that are not that important, but will make it a little bit more pleasant to work with this application. I'll start with changing a bit the titles of our screens. So here we have search on the home screen, but on the search itself, let's go into the application search ID. Maybe not even here, maybe in the layout. Let's do here application dot search / ID, and let's do title search up search without parentheses should be okay, or search products, or okay. And here the header back title is going to be empty string. So if I go here, header back visible, maybe not like that. No, I want header back title visible false, to only hide the title and leave only the back button. Okay, now it's better. Okay. Nice. Another thing that I want to improve on is the types. For example, the searches at the moment is of type undefined. That's because in the utils on the Supabase, when we create the client, we didn't specify what type should the client be. Supabase can automatically generate TypeScript types based on our database. So if I'm going to search Supabase TypeScript, there is this guide that will help us generate the types and use them in our application. So to generate the types, we need to run Supabase gen type TypeScript and then project ID. So let me go ahead here. Let's open the terminal. Let's do clear, and I'm gonna do Supabase gen types. I'm gonna do -- linked to use the linked database. Based on that to generate the types, and I'm gonna save them in types, then supabase.ts. Let me go ahead and create this types folder because it needs to have a folder and it will create a new file there. If I press enter, Supabase now will generate this file for us automatically, and this file has information about our tables, our, for example, product, searches, and so on. So it has all the types that we need. I'm gonna close it and I'm gonna go back to the utils file, and here we can go ahead and do import database from types, and then these database types we can send it to the create client, and just by doing that, now Supabase is typed. Now Supabase, whenever we use the Supabase client, most of the things will already be better typed. For example, if I go to the authentication, not authentication, but maybe application search ID, we're gonna see that by doing Supabase from searches, the data, if we hover over it, it's going to know that the data is of type search. So now we type the data, but we should also type our state variables where we store this data. For example, this one, we want to say that, hey, this one is of type, the same type as the type of our table searches. So what can we do? We can use tables, import it from our types Supabase, and here we're gonna use another pair of angled brackets to target specifically the searches table. And just like that, these are the search. Let's also do war null and initialize it with null here. Well, not here. Yes, like this. So this search is either null when we just launch, or it's going to be of type table search or search table. Now, when we call set search, it knows that this data is from there. And if we make a mistake on the table name, Supabase will know that and say like, hey, first of all, there is no table like this. And second of all, the data type does not match the searches here. So it's going to be much smarter and it's going to help us make less mistakes over time. And here, set products, we can do the same here. The search product types is going to be tables, products, and the type is going to be array because we are going to do array of it. And this is not array, this should be like this with angle brackets like this. And it's not going to work because here we are querying product searches and we are also getting the products from there. Let's think products. At the end of the day, we are still taking the products. So data knows that it's a product or it's null. So let's do data. Let me think. Data and it's an array. Okay, data.map. Maybe then we're gonna do .filter so that we only keep the products that are not null. And probably you should do it as products array. Not products, but tables. Products. TypeScript will not understand like the filtering and the mapping. So now if I go here, okay, it works. Set search payload.new. Payload.new. Yeah, the payload here is not typed. How do you type this Supabase channel on? There should be a way to type this one as well, but I don't really know how to do it for the subscription. I just know that this is going to be, the payload new is going to be of type search, because we are listening on the table searches. And in the tabs index here, for the search, for the history, we can say that the history is going to be tables of type search, and it's going to be an array of them. Let's import tables as well from our database types, and when we fetch the history and set it back, it should work. I don't know why it doesn't. Searches, like this. Okay, it can also be null. So let's do data, set history data, or empty array, because data can also be null if there was an error above. Now it works. As you can see, like all of these changes that we're doing, like or empty array, this is actually helping us prevent bugs in the future. Okay, that's good, that's good. The use of doesn't know like that it can have a user, and I'm gonna go into my context, of context, and here we need to specify what type this context is. This is just simply creating manually the type of context type, and the type, we can look at what we are exporting here. We are exposing a session and a user, so we can say session is of type of something and user is also something. The session is going to be of type session. Let's do that, and Supabase will, I guess it should be of session like this, and the user is going to be user imported from also Supabase. The user can be null as well, so let's do or null, and let's give our create context this type, and because we already have a type, we need default values. For example, session is, let's also do where null and initialize it with null, and user as well null. So user undefined, let's do war null. Okay, perfect. Now when we use of, it knows that this is of a user type, but it also knows that user can be null. So you should be careful here, like if user is not defined, return. That's also true. But in a way, we know that if a user is not authenticated, he is not going to be on this page, because in the layout, we are checking that and we are redirecting away. But TypeScript doesn't know that, so we need these extra checks just to make sure. Same things here. Okay, perfect. And for the search ID here, everything is fine. Will remove dummy imports. And I can do git status, git add, git commit, refactor, and add TypeScript support. Okay, perfect. Zwilly Finney is saying, I'm doing well. I was trying to integrate with more entities, Amazon, eBay, but the issue was on the tables. I'll have to work around Supabase to fix that. So the issue was on your table, on how you structure the data. In that case, yeah, what we did is we copied, or we took inspiration a lot from the data structure of the Amazon API from BrightData. So things like async, create data, and so on. In your case, you need to build like a very reusable one here on Supabase. And then, yes, you can go ahead and integrate our e-commerce data as well. Not only Amazon, but maybe also eBay, right? Under the eBay, we can go ahead and discover by keywords. And here under dictionary, we're just gonna map like, okay, we already have URL. So this URL, we're gonna put it in the URL of our product. Here, we have product ID. We're gonna take product ID and put it in the async. We have title. We're gonna put it into the name. We have images, which is an array. We can take only the first one. We have price, we have currency. Yeah, we have like a lot of common data. It's just a matter of mapping it properly and putting it in our table. And if you have multiple sources on the product side, on the product table, I'd also add a new field called source, and there I will put Amazon or eBay. And actually, that's a very good thing. Like if we manage to do it, I think we should also integrate this one. I used interfaces. I didn't know how to do it. That Supabase types could be useful. Yeah, with Supabase types, like we don't have to worry about keeping them up to date, because every time we do some changes on the database, we're gonna run this command again, npx supabase gen types, and it's going to look at the database and generate the new types. So we don't have to manually keep our types in sync with our database. That's really powerful. And yeah, like much more automated. And you can also download them from here. Don't really remember where, but from the API docs, you should be able to go ahead and download the types if you don't have like the local environment set up. But it's not that complicated to set it up locally. All right. Okay, so another thing that I'll check if it's not too complicated to fix is going to be like if I go here to iPhone, which is a search that we scraped multiple times, we see some duplicate keys. That usually means that we have duplicated items in our data here, and we could actually see that that some of the items are duplicated, which is not exactly what we wanted. Because if we look at our database, where is it? On the visualizer, where is the schema visualizer? The way we designed our database is that a product search, like whenever we type something, that's going to be stored as a one line in the product search. It's going to contain, where is it? The search. It's going to be stored in this table called searches. A search is linked to one user, and the search will contain what is the query, like what you're searching for. Now, we go ahead and fetch products from Amazon and we store them in this products table. The thing is that if I am searching from an iPhone and you're searching for an iPhone, I don't want to duplicate the iPhone product in the database. So that's why I did not link the product to the search. Instead, I kept it unique so that if both of us are looking at the same product, it's going to be one item in the table. And if, for example, this will also optimize a lot of unnecessary scraping, because if I will do an updated scrape and will update the iPhone in the database, you're also going to get that update automatically. So the more products we're scraping, the easier it's going to be, because there will be a lot of overlap if we are not duplicating them, but keeping them unique. So where is the duplication coming from? The duplication is coming from the way we linked searches and products. We link them correctly because whenever we have a many-to-many connection, a many-to-many connection, in our case, it's between the searches and the products. When you have a many-to-many connection, let me do it like this. So when you have a many-to-many connection relationship where one search can have multiple products, but the same product can belong to multiple searches, in that case, you need to add a new table that will make this connection. That will do a one-to-many connection between the search and this table, and one-to-many connection between products and this table through this search ID and async. In two ways, one-to-many, and in then we get this many-to-many. The problem is that whenever we are scraping them again, we are not duplicating them in the products, but we're duplicating them here in the product searches. And we can see that if we go into the table editor, we have only 71 products, but in the product searches, we have 90, which means that now if I'm going to do one more here, if I'm going to start scraping iPhone again, it's scraping. So remember, here we have 90. On the products, we have 70. We had 70. Now it's 71. It's done. So it only found 2 more items to 72, but in the product searches, it inserted 10 more. So as you can see, we are duplicating it here over and over again. So how are we gonna fix it? Let's see if we can fix it on the database design. If we can do that here. I have a feeling that what we have to do is we have to say like the combination of a search ID and async should be unique. If there is already a search ID, an item with this search ID and with this async, we do not have to create it again. So maybe I'm going to make them primary keys, and I'm going to simply delete the ID because it doesn't need an ID. And the created at maybe also doesn't need, because yeah, created at, does it need created at? Maybe not. So if we make search ID and ASIN primary key, what does that mean? That means that is unique. Let's think about that. Supabase, many-to-many connection. ID teams members user ID. Yes, as you can see, there are users, there are teams, two tables with many-to-many relation between them. So that they created the members with user ID and team ID, and they created a primary key based on these two fields. They do not have anything else on the members, like an ID or created at. And I think that's what's going to automatically power this uniqueness of search ID and ASIN to be only one. Let's try to save. Maybe it's going to fail because we already have some data. Yeah. So how are we gonna change it? Should we simply delete all the data for now? Because we are in development, it's not that complicated to delete all of this data. Reload. We have search ID and ASIN. If I do edit table, no primary key. Save. It cannot save because it fails, because there are already some duplicated things. It correctly removed ID and created that. Now I'm going to simply remove all my items from here, delete rows. Unable to delete rows as table has no primary key. That's a bit weird. But I can go into the SQL editor and say drop table. How's it called? Product searches. Don't do it yet because it's risky. Let me try it first. So the following has, okay, query destructive. Let's try. No rows return, but it removed that table. Yes, you can go ahead and execute this drop table, and it's going to delete the table completely. And we can create it from scratch, called product searches. Is that how we call it? Just to have the same name. I don't really want to reinvent it and have to update it in a lot of places. It's called product search. So it's called product search. It's not going to have an ID. It's not going to have a created at. It's going to have two things. It's going to have, let's also use the same name for the columns, ASIN and search ID. With ASIN, it's going to connect to products, to the ASIN of a product. ASIN is a unique identifier for a product. And when a product is removed, what should happen here? Well, probably also remove, so cascade, cascade. And the search is going to connect to a searches ID. Like this, save. And let's make them primary by selecting both of them and creating a composite primary key based on two fields. Now if I save, adding two columns, and it correctly saved. Now if I'm going to reload my application, we lost the relationship between the searches and the products that we have there. But let's go ahead and look at where we are inserting these connections. We're doing that in our Supabase functions. When we finish the scrape, so when we get information from the scrape job, and here, as you can see, we have link products with search IDs. We are inserting async and search ID, and that's it. Nothing more. Let's try to go into iPhone 16 and start scraping again. And if everything worked, it should keep the uniqueness of a relationship between a search and a product and not duplicate it. Let's see it in practice. Still scraping. If I look at BrightData here, for the logs, it's still running. That's another thing I love about relational databases. You can put some constraints on your table, and it's much easier than putting these constraints on the application side, like having to check from application, like is it unique or not? Is it already there or not? Something didn't work, but no, actually it worked, you see? But I don't see why there are no products here. There is search ID 20 and async. Let's see how we are querying them in our application search ID. Because we updated the tables, we need to regenerate the types again. So let's do npx, come on, npx Supabase gen types again. And now if we have some issues with TypeScript, it's going to tell us. But let's look at how we are looking for products. We look at product search. Product search. We are looking at everything and taking the products. Does it have correctly this link? Products. Search ID equal to ID. Console log data and error. Let's see data and error. Oh, I know. In the product search, because we recreated this table from scratch, it doesn't have these RLS policies, row level security, and by default, we're not allowed to read anything from here. Let's go ahead and press on go to table editor to product search and add an RLS policy for the select read access for all users. Let's do save. And now if I go back to the application and reload and go to the iPhone 16, we should have these items. And if I do, let's start scraping again. In our product search, we have here 10 records. We should not expect more than, I don't know, 11 or 12, because yeah, maybe it found one more item, but it definitely didn't find 10 fresh items. So let's wait while it's scraping and make sure that we are not duplicating the items in our list. And for some reason, scraping the iPhone query is the longest. It's 1 minute, while the others is 9 seconds. So probably we should look at others. For example, I can go to LG TV, start scraping. Let's see how long it's going to take. And we have like a couple of them in parallel. The iPhone already is here. And it's 13, so it found 3 new items by doing a new scrape. And in a second, we're gonna have Amazon, which is going to have a different search ID. Here it's ready. So yeah, it's a different search ID. It's 18. So yeah, now if we do multiple scrapes, we're not gonna have duplicated items. Perfect. Let me go ahead and do npx Supabase db pull to pull the changes from the database. I mean the database structure, not the database items, so that we store it in our source code and you also have access to these changes that we just made. Let's do yes. And now I can do git add, git commit -m, unique product search relationships items. Okay, nice. Okay, I think it's time for price history, right? To be able to store the history of prices and to track them over time. How are we gonna do that? Because in the products database, we have here the final price, but this is the current price. And I would like to keep this table as a representation of the current state. What is the price at the moment, or let's say at the time when we last scraped Amazon, what is the title, price, and so on. And I want to keep the history of the data separate. So either we can go ahead in the products and do an edit table and create here price history of type, let's say float, and then we define it as an array. That's also possible, and I'm thinking maybe I should do that. Or we create a separate table where we keep snapshots of product information of the fields that we want to track over time. And that one, the second solution, this solution is good because it's easy. It doesn't need a separate table. It works with one single table. But with this solution, queries are going to be a bit more difficult because it's going to be a bit harder to say what is the lowest price for an iPhone based on different products. Like, it's going to be harder to do this kind of queries. So I'm gonna cancel these changes, and instead I'm going to create a new table that is going to store snapshots, historical snapshot of our products. Product. Should we do history or snapshot? Snapshot. Let's do snapshot. A snapshot of the tract of the at a specific point in time. So what are these snapshots going to have? They are first going to have an async because we need to connect them to the product itself. So a snapshot is related to an actual product, by this async column. And if we delete the product, we delete his snapshots as well. And it's going to have created that, which is a very important field, because the snapshot needs to know like when it was created. And it's going to also have the other columns that we want to track. Columns similar to the columns that we already have in the product. Where is the product columns? So product, similar to these columns, but I don't think we need all of them. If you want to track changes on all of the columns, you can add them, but I'm only going to track the final price. So let's do here final price of type float, and it's going to be, let's do is nullable false, there as well is nullable false. If you want to also track, let's say the name, if you're doing, maybe if you're building an application that has something to do with search engine optimization, to track like how a product changes the name over time, you can track the name. But in my case, I don't care about the name or how the name changed over time. I care about how the final price changed over time. So I'm gonna add this final prices column. And I think that's it. I'm going to save this table. And I'm going to update our function, our edge function called scrape complete, that we can find in Supabase functions, scrape complete. Because this is a function that is being called whenever we get scraped data. And what we do here with that data is first we save all the products. In our products table, then we'll link them with a search. Maybe I'm going to, let's leave a console log. So another thing that we need to do when we are scraping is we need to save a product in our database, which is the current version of a product. We need to link it to the current search if it's not already linked. And lastly, we need to save a snapshot of it for historical purposes, a snapshot that is not going to be changed over time. Because this one, we are using upsert in the products, which means that either insert or update. In our case, we're going to have here, let's remove this comment because we fixed it. Update our status. Let's go above. Before we create the links, I'm going to do here save product snapshot. So let's again do the same mapping for the requested data. Product snapshots. We're working with an array of products. So we need multiple snapshots. And for every product, we need its async, because that's how we create the connection. We don't need updated that. We don't need name. We don't need image. We don't need URL. We only need final price. We need the async because it's for connection, and the rest of the fields that we added in our product snapshot for tracking purposes. Now we have a product snapshots. We're going to call a similar function as here called product. Let's do snapshots. Let's console log them. So let's insert the product snapshots, not with upsert, but with insert, strict insert. And the table is going to be called product snapshot. Should be plural, my bad. It should be snapshots, but I named it snapshot, so I'm gonna go with it. A recommended way is to have plural for table names. Product snapshot. So here, when we get data from a scraped information, we are saving them in snapshots as well. Let's go ahead and deploy this function. npx supabase function deploy. Hello, Gyurke. How are you doing? Hello, MJD. And let's try to scrape again iPhones. And if everything works correctly, we should see also product snapshots with the final price here. Gold Hunter is asking, please make a video on how to build an application and use EAS properly. I worked on Instagram clone application, but unable to build the APK file using EAS cause of lots of errors. EAS, yeah, Expo is working on something new there, which I cannot disclose, but whenever it's ready, we're gonna try to do a tutorial on it, on EAS. So there it's done. Here it is. Here is the price history on this date at this time for this product. And if we go ahead and you see products, we have 87 here. If I refresh, it's still 87. And snapshots are 10. If I go ahead and scrape again this product, in the products table, we're not going to have more than 87, or maybe 1-2 more because of new items scraped. It's done. So if I refresh, it's still 87, but in the snapshots, we should have 10 more because these are 10 more data points for these 10 products that we scraped at a different time. So that's how we are building the history of the items. And for example, if we go ahead and we want to see the price history for the item with this ID, how to copy it? Let's expand and copy it like this. And if we filter based on the async, and if we apply this filter, it's only one. Probably the one. Let's look at another one snapshot here. Probably it didn't pick up the second time when it searched. This one. For example, let's try this one with JD. Where is it? So if I filter based on async JD, apply, we're gonna see 2 data points. So on this date, it was 1,119, and here as well, because we are running these scrapes at the same time. But if I would run it multiple times a day, we're gonna see here different prices if it actually changes. So by simply filtering here on the async, we can see the history of prices. Perfect, that's good. Let's go ahead now and display that in our application. To display that in our application, first of all, let me do Supabase. Supabase. Did I do? Let me do, DB pool, because we added a new table and I don't remember if we pulled it yet. Yes, and let's also do npx supabase gen types to regenerate the types. Nice. Now I'm gonna do git status, git add. product snapshot for historical prices. Product snapshot table. Okay, now let's go ahead and see where we're gonna render this information in our application. I believe that we're gonna, for example, click on one of these items, and I want to open a new page where we can see either a graph or a table with price changes. So let's go ahead and create actually a new page where under application search, maybe we're gonna create a new folder here called product, and we're gonna create the product details page, id.tsx. This is going to be the page that will render the default product details. Let's return. I'm gonna start with a text product details. Let's import text from React Native, and let's redirect to this product details page from this list, from the search ID. We have here the pressable. This on press that opens the link which redirects to Amazon, we're gonna need it on the details page, so I'm not gonna delete it, but I'm gonna comment it out. And the whole item, I'm going to put it into a link that will redirect to the URL of a product. So slash, let's do it like this, slash product slash, and here the item.id or item.asyn. And in the product, probably it's better instead of ID to call this variable asyn, because the asyn is the unique identifier of a product. And link should be imported from Expo router and also rendered as child here. So now if I go back here and if I press on one of these items, we are redirected to a screen that is not yet added, but if I reload and do that again, we see the product details. Perfect. Let's go ahead and copy some of the things that we're rendering here for one of the products in our details screen. So I'm going to copy the whole render item from here into the product page. Let's render it like this and see what we don't need. For example, I don't need the link, so I'm going to remove link and link. I don't think I need a pressable. I'm going to replace it with a view. Let's import view from React Native. Let's import image from React Native. And we need the item. Where are we going to get the item? Well, we need to fetch it. So const product set product, it's equal to use state. Initially it's going to be null, but the type of this product is going to be tables, products, or null. Let's replace item with product, product, product. Let's also check if there is no product. Let's simply return a text saying product not found. So if now I'm gonna go there, I should see product not found because we didn't fetch the product yet. Well, how do we do that? Let's first, where is it? Let's first take the asyn from the search parameters. Use local search parameters. We can type this one and say that it's going to have an asyn of type string. So we're going to take the asyn, and in a use effect, we can go ahead and do, hey, Supabase, fetch from the table called products, select all the columns where with equal sign, where asyn is equal to asyn, and let's do single because I only want the first item, and then simply set it in product state. Just like that. What is happening? Something is happening, probably not exactly what we need to do. So products, set product. Oh, because here we're gonna get data. So we're gonna get the data and call set product using data. Okay, here we have the item, which is fetched directly on the page. So if I go here, we see that it's actually the data from there. Okay, cool. What we need to do now is the snapshots. Is on this page, let's query the snapshots that contains historical data about prices for this specific product. So product snapshots, set product snapshots, use state. This is going to be an array of type tables, product snapshot array. Now in the same use effect, fetch price snapshots. Let's go ahead and do again Supabase dot from the new table called product snapshot. We're gonna select everything. I'm doing it for two different fields, for two different queries, but actually you can do that through the same one here. So maybe I should do there. Let me do it for one single thing, because whenever we are querying related data, we can fetch products, get all the columns, but also get the columns that are related from another table. For example, product snapshot, and there all the columns from the linked product snapshots as well. So the only thing that's left is when we get the data to say, hey, set product snapshots with data dot product snapshot. And let's try to console log it here to see if this is the name. Oh, not here. So if I go here and here, we see empty. Probably messed up the name. Maybe it's snapshots. Products and product snapshots, but no matches here. Yeah, it should be product snapshot. Oh, I know why. So there is no error, but at the same time there is no data here. That's because of a RLS again. By default, if we do not have any rules on who is allowed to read from this database, nobody is going to be allowed. So under product snapshots, let's go ahead and press add RLS. Let's create a policy and say that anyone is allowed to read, maybe only authenticated. So you can go ahead and press authenticated here to protect your data. Let's do save. And what's happening? Yeah, I think it's successfully created. Now if I'm going to reload and go to one of these products, yes, we see some history under the product snapshot. Let's do war empty array like this. Okay. So now that we have an array of historical data, we can go ahead and render it somewhere on the screen. We can do that by putting this thing as a header of a flat list. So I'm going to start by adding here like this, not to. And after the view, let's render a flat list. With data, I'm gonna call it snapshots. How is it called? Products snapshots. And in render item, we need to render the snapshots, the price history. We're gonna take the item and we're gonna render it in a view where we have a text for the created at, item.created at, and another text for item.final price. So if I go here to iPhone, something is wrong. Let's check where, yeah, the flat list was imported from gesture handler. Should be from React Native. So now if I go to iPhone here, we're gonna see two items. They're not very nicely designed, but at least they're there. Let's go ahead and give here to this view a class name, because we are using Tailwind, Flex, and Flex row, and justify between to put the space between. Okay, let's do padding 2 and BG white. Nice. On the flat list itself, on the content container class name, let's give it a gap 2. Okay. Okay, and we can take the currency here and put it like this as well. And what else? Here is the flat list. Now we can take the whole view from the above and put it in the flat list as the list header component. Let's put this view. And now everything looks like a list and we can scroll through it. Probably this view, I'm going to put another view around it to be able to add something below, like a text with price history. And let's make it semi-bold. Okay, so here we have it. I think that the created ad should definitely be put into a day.js with .format. Let's import day.js, and how we're gonna format it. let's do the JS format. Let's see something from here. For example, this one. Yeah, I think looks good. Okay, October 4th at 4:45. It was this price. At 46, it was that price. If we go ahead and manually change some of this data in the database, we're gonna see it. It would make more sense if we run this scraper like over and over a longer period of time, because it's obviously not that fast for this specific product. But in the snapshot, this is the item. Maybe it's this one. Let's do 999. And we see it here. Perfect. So hello, go full stack. Do you still type question mark? Where exactly? And what do you recommend? Try Shadowscape theme on VS Code. I'm not that person who tries a lot of themes. Like, I have one that I've been using for the last probably 4 years. Never touched it. It works for me. It looks okay. And if you're interested, that's, I think, Material Darker or something like that. Okay, so now we are visualizing the price history. Git add, git render price history snapshots. But at the same time, we do not have the button to open it on Amazon. So what I'm going to do is, where do we have it? On the async here, in the list header component below the top view, let's do here a button. Maybe we can try the custom component button from the components with a title open on Amazon. And on press, it should do this linking open. So let's make sure to import linking from React Native and item URL. And it's only going to be available, this button, if item.url is defined. So let's do it like this. Can't find item. Well, because it's not item, it's product. So if product.url is defined, let's open his URL. Okay, looks nice. I'm gonna give it a class name. Will it work with class name margin 2? Yes, it works. So if I press open on Amazon, it's going to open it here. Are you going to add a graph to track the pricing? I think that would be the next step. So let's go ahead and do git add, git commit open on Amazon button. And let's push it. But if product.url, let's do it like this. Why is that? Product URL can be null. And here we are checking if it's true. Okay, so give me a second. I'm gonna bring some water and we continue because we still have to visualize better. I'm thinking to add a graph there. I would like to track searches and automatically run scraping jobs for the tracked searches, and that's going to power our price alerts. Maybe we're gonna do first like the tracking and price alerts and then the visualization. But we still have a lot of things to do. I'm gonna be back. Go ahead and drink some water, take a short break, and let's continue this project to bring it to as close as possible to a production-ready application. I'm gonna be back. Hey, yo, I'm here. While we're waiting, LinkedIn or Twitter handles, let's connect. My LinkedIn and Twitter handles are Vadim notjust.dev. Go ahead, follow me on Twitter, let's connect there. And on LinkedIn as well, you can find me at Vadim Savin, something like that. And here is what I was working on just before going live. A game in React Native. Like everything started yesterday. I wanted to see if I'm working on the course on the React Native Mastery, and one of the projects there. Let me go to one of the modules. React Native Mastery is the course that I'm working currently on. It's going to launch in a couple of months. And this is based on, this is going to teach you everything about Expo and React Native, and it has 7 different real projects. And the 6th project is a game. So I have everything ready. Now I'm working on this game, and I've been sharing some resources here because with this project, I want to teach you about animations with Reanimated. I want to teach you about gestures. So as you can see, I've been having quite a good progress with collision detection, building like this really simple game. And here it's even has these gestures. So we can use gestures to control the ball direction, as you can see here. And then, yeah, it's almost ready. It's a fun project. I'm very excited about it and can't wait to get into recording it. And if you're interested, make sure to join the waitlist here. It's going to launch in the next months. And if you join the waitlist, I'm gonna make sure to let you know whenever it happens, and it's going to have some nice benefits if you're on the waitlist. Okay, so what are our next steps? I want to visualize prices on a chart. And I also want to implement the tracking of the searches to automatically run scraping jobs behind the scenes without us even opening the application. And whenever price drops, to send price alerts. Let's think from, like, let's say a product perspective, like how would you implement that? And I would need your opinion here. Would you track a search saying that, hey, I'm looking for an iPhone 16 and I want to track this search, And whenever any items from here changes price to receive a notification, where do we want to track specific products? That's a good question. Because whenever we are tracking the search, the same search will give us different results. But at the same time, I might not care, like, is it from this seller or another one? I'm just looking for an iPhone and I'm just interested in a lower price. But at the same time, we have for the same search result things like this one, which costs 0.01. And it's not even found. Not sure what's happened there. Probably it was deleted actually. Yeah, it was deleted. Rusty. So what do you think would be the best approach to track and to subscribe to a search or to specific products? Let's even see if we are going to be able to get to scrape a specific product. I'm gonna go to e-commerce, amazon.com. There is Amazon products. Collect products by URL. Is this what I'm looking for? Amazon product URL. Yeah, I think I would be able to do that. So you just specify URLs and back you get data. So we can scrape and track specific products. It's going to have asyn. It's going to have URL and final price. Let's see. Final price. But that would be like a different yeah, I think I am going to implement tracking of a search query, because we already have these functions of scraping a search. Later on, we can also implement like additional features to track a single product. And for that, we need to simply integrate with a different web scraper API from BrightData, which I just showed you there. It was called e-commerce Amazon products by URL. So here you simply send a URL from your database and you get back information scraped from BrightData for that specific URL. And you can even send like multiple URLs at the same time to do it in bulk. But what I want to do is I want to say like, hey, as a user, the search, let's say iPhone 10, I want to track it. We already have this isTracked field, which is a Boolean, which is initialized with false. Let's add an icon on this list, or maybe, yeah, let's start with a list. So on the application, let's go to tabs index. In the flat list, we have this pressable with two texts. Let's go ahead and add an icon at the end from Expo, vector icons, to track. How do we do it? Or bell. I think it's a bell icon will be nice. So where are we gonna take it from? Okay, I like this one. Let's see if we can render it. I'm gonna import it at the top. And let's render it here. In the flat list, when we render the history of our searches, I'm gonna render the icon here. And I can put the two texts above together, so that on the pressable we can say flex row to put them in the same row, justify between to move them apart. Come on, justify between, and also align center or items, item center. Nice. Now this one is going to be dim gray is good, and 22 is perfect. And it's going to be either bell or bell fill, depending on whether this thing is struct or not. So let's go ahead, and the item has that is struct field. So I'm going to use that here for the name of the icon. Item is struct. If it's struct, then the icon is bell fill, otherwise is bell. Just like that, all of them are unselected because none of them we are currently tracking. Perfect. Let's go ahead and also add this icon on the detail screen. On the search details here, we have start scraping. Where are we gonna put it? Again, somewhere here. We can, let me just add it and then figure out how to style it. I need to import octicons at the top. And instead of item, that's going to be search. Where is it? If search is tracked, then bell fill. Okay, that's good. How to style it better, this component. Let me put them in a view like this. I'll move a button outside, and this one is going to have flex row and justify between, and the margin to maybe some padding. Where is padding? Padding 3. Oh, I already have padding 2, so padding 4 is good. Let's also do item center, so that the icon is going to be there in the center. Okay, so now we have an icon. last thing is to go ahead and implement an onPress event that will update the isTracked field of our search. So let's do toggle isTracked. This is going to be a function that we will implement at the top. And let's do that through Supabase dot from the searches. I want to update the field isTracked, and I will change it to the opposite of what currently isTracked value is. But I will only want to do that for the item based on the ID, where the ID is equal to search.id. And we can even select it back as a single value. So we can do const data and error, because with this data that we receive back, we can set and update the state. And we can do here only if search.id do that, or in other words, if search ID is null, then return. And here with a question mark. So if I go here and press on this icon, I'm not sure if something happened, but I can reload and see. No, it didn't. But let me check permissions. That's almost always the case. I'm going to go to the searches and off policy. We have insert, we have select, we have update. Based on their email, what? Based on, it actually checks the ID, so it should work. Extract search ID. Oh, I forgot to negate it, so I need the opposite value of the isTracked. So now if I go here and press this one, it's updated to isTracked, and now in the database, we can see that, hey, there is one search the search request that the user wants to track over time, so that value is true. Now if I go back and if I reload, we're gonna see that here as well, this field is tracked. Okay. So now it's simply, we are allowing the user to specify what searches he wants to track. I'm thinking to also show all the tracked searches in the second tab under price alerts, because it's not that complicated. We can take a lot of inspiration from the tab's index for example, fetching the history. And I'm going to actually do that. Let's take the history state from here, from index, and go into the tab 2. At the top, let's import state, let's import tables. Let's see how we are fetching that data in the index. Fetch history, it's a function, and a use effect that triggers it. Let's call it in table, in the second screen. We need the user, and the user is going to be taken from the use of. The Supabase is going to be imported from utils, and the use effect should also be imported. Now the last step is back in the index, is to see how we are rendering this list. It's basically this flat list. Is this the time when we extract the search item in a separate component? I think it is, because I would duplicate the whole code here, and I don't want to keep updating this item into different places. So in the components, let's create a new file called search list item tsx, and let's do export default function search list item, which will return and render one of these rows. The rows is this link from tabs index. Let's paste it here and let's start importing, for example, link from Expo router, pressable from React Native, view from React Native, text also from React Native, octicons from vector icons, and the item, or yeah, let's do days.js. And from now, actually we'll need this part. It will need relative time import for the days.js, and it will need the days.js.extend relative time. And the item is something that we're going to receive here in the props, and as maybe not item but search, and we can even type it search is of type tables from Supabase searches. So now let's replace item with search to be more specific. And let's go ahead. I don't see any errors here now. We can go ahead and import search list item in our tabs index and render it in the flat list where we took it from. Let's make sure to import it from our components and send there the property search, our item. Okay, now our home screen works as it was working before. Now we can safely copy the flat list and move it to tab 2 and render it instead of this container. Let's make sure to import flat list and the search item. And if I go to tab 2, we're gonna see the same items here. That's good, but what I'm interested in here is actually a condition here under equal. I want only the items that has the isTracked equal to true. So if I do that, I will only see the price alerts, the items from this list that are marked as isTracked. I think I'm gonna put a view here with a class name bg white and a flex one to make the background white. Perfect. And if I'm gonna go ahead and also track, like let's say a MacBook M3, track this one, go back to price alerts. It's not watching it automatically, but the next time we go here, it's going to be in this price alerts where in the searches that we are tracking. So we can again press on it and we're gonna see it, the different products. Okay, so that was our the easy part, visualizing and managing the tracked searches. The next step is going to be to actually track them, or to actually run the scraper whenever at intervals of time. So let's do a git add git commit track searches UI. Hello Fulbright, how are you doing? Hello Shadab, how are you doing? Shadab is asking, can you suggest where to learn about inference of machine learning model? I'm not even sure what inference is. Inference machine learning is the process of running data points into a machine learning model to calculate an output such as a single numerical score. This process is also referred to as personalizing a machine learning model, or putting a machine learning model into production. Oh, I don't know about that. or basically like using a machine learning model, right? Yeah, like running live data points into machine learning algorithm. Like after you train it, you use it to get data. Yeah, don't know what to recommend you. Doing well. It's been a while. Thank you for the great content. Yeah, Fulbright, I remember you. You've been a very old subscriber on our channel. How has it been for you? Long time no see. Okay, so what do we want to do? These searches that we mark as tracked, like where we want to track them, what we should do is we basically should create a system that would press this start scraping button automatically for us at different intervals of time. Maybe daily, maybe every hour, it depends. Maybe you can even have like multiple tiers in your application based on a subscription model, so that the free version is going to scrape it once a week, and the pro version is going to scrape it daily, and the gold version is going to scrape it at every hour. You can do that as well. But what the next step, yeah, as I said, is to start this scraping process automatically. The scraping process for us, it's working. We can trigger it manually through this link, as you can see here, by invoking the function start scraping. We are also automatically tracking, starting it or invoking it whenever we insert a new item in our database, a new search item. But we also have to invoke it. This is this one. Using a CRON. Let's take this one, which is going to look bad. So at every interval of time, go ahead and invoke a new scraping job. I'm gonna make this one green because it's already implemented. And this one, start or scrape tracked searches every X hours. I don't know. Oh, come on. So the part that would invoke this this CRON, or that would run at that will power this running something at intervals of time, we can have a look here, is something from Postgres itself. So Supabase CRON. So the Supabase has an extension called pgcron. So with pgcron, we can schedule jobs. We can enable that extension, and we can basically add a row in our database and say that, hey, based on this expression, run this function or do this thing. So as you can see, you can run crons to basically do operations on the database, but together with another extension, pgnet, which allows us to invoke, send HTTP requests from Postgres, we can put them together and say, hey, every 30 seconds, go ahead and send this net request to this Supabase function with this body. All right, so that means that we're gonna have, where is this one? Okay, that means that we need another edge function. Let me move them everything down a bit. Because this cron job is going to invoke a different function, edge function. For tracked product searches. So look what we have to develop. Like everything that is with brown, that's not yet implemented. We're gonna create a new function that is going to look through the database, find all the items that should be tracked, and it will invoke this start scraping function. Then the main function that will start all of these multiple jobs is going to be triggered by a CRON. So let's start by implementing this function from here. For that, we're gonna go ahead and do clear npx supabase functions new, and let's call it scrape tracked or start, or how to call it, scrape tracked searches. Not the best name, but you get the point. It's called start scraping for tracked searches. We have a Supabase function here, scrape track searches. What we need is we need to first go ahead, and I will probably remove some of this stuff. We need to first fetch all the tracked searches. So for that, we need access to Supabase, and we will look into the previous functions. How did we get access to Supabase? First of all, we imported create client. So let's import it here at the top. Then we created that client like this. It's not gonna depend on any headers. Let's do, I don't know. Okay. So we created the Supabase client. Now we need to get all tracked searches. Const data and error is equal to await Supabase without importing it. And let's replace Supabase client with just Supabase. I want to do from searches select. In this case, you don't need to select everything actually. We just need, or maybe we need everything. Yeah, let's select everything. And where that is tracked, or how is that field called? Is underscore tracked. Where is tracked equal true. let's do, yeah, that's it. Now we should have this data here. So let's do a console log data dot length. Let's call it maybe searches. I will also do a console log error. And what I'm going to do, I don't need this import Supabase. That's wrong. Doesn't look right, but hopefully that's just simply my environment. Let's try to deploy this function. Git status. Let's do npx Supabase functions deploy and see if we are getting the right amount of searches from the database that are marked with is_tracked. If I go here under the edge function, we should have a new one, scrape tracked searches. And if I invoke this one, and how do you invoke it manually? Can I? I have endpoint URL. I will invoke it by sending an HTTP request. Here is a remote request example. Let me copy it in my code. Remote request. Hopefully this is the ID of my function. The name of the function is called scrape tracked searches. It should match the name of a function. The authorization, this one should be updated most probably because I updated it. So I'm gonna remove everything except bearer, and I'm gonna go to the API project settings under API, and I'm gonna take that a non-public key. I'm gonna take it from here and put it here. And then I don't need any data actually. And let's try to take this curl request and send it in our terminal. We should see OK back. Yes, we see OK. And if we go to our edge functions, to our function logs, we should see 2, but in fact we see 0. Most probably that's because of the anonymous key that we are using, right? If instead of anonymous key, I'm going to replace that with the API service role key, that's going to bypass the rules for authorization, and it should work because whenever we're going to invoke it, let's try curl. Okay. Let's try now to look at the logs. We should see new logs. And here we have length equal to 2, which means that it correctly queried and got the list of searches that are tracked. Now for every search here, we should basically invoke, for every search from this edge function, we should invoke start scraping and send there the record. So what we have to do is we need to invoke the function. We remember that we could invoke it on the start scraping button. And if we see at that button under application, search ID, start scraping, that's basically Supabase functions invoke. We can do the same because we have Supabase function in our functions, scrape tracks. In our edge function, Let's paste this one here. And we need to invoke the scrape start for every single search here. So what I'm going to do is I'm going to do searches.map for every search. Go ahead and invoke this one. And it's going to be an array of promises. So I'm going to put them into an await promise.all. Await promise.all in order to wait the execution of all of these invocations. Await like this. And I don't need the things on the bottom here. Promise, what's wrong with promise.all? Await promise.all. I think it should work. I think it's just Dino not liking promise.all, or maybe Dino doesn't support promise.all. I don't know. We're gonna see. We can even take a result and do a console log result. Maybe a JSON.stringify is gonna help, because we're gonna have the result of a couple of invocations. Searches. For every search, we are invoking this one and sending the data there. Okay, let's try that. Let's try to deploy again the function. And hello, Manpreet Singh. How are you doing? Manpreet Singh stumbled on your channel just now while looking for how to use AWS Amplify Cognito. We'll be using with Svelte. Wanted to ask one small thing. Will the video work with latest tutorials? Will the videos work with latest tutorials, latest versions? So with AWS Amplify, some of them will work, but I cannot promise that everything is going to work, because some of our AWS Amplify content is quite outdated. I mean, it's like 1 or 2 years, and Amplify has a lot of changes. But it's more about Amplify, because if you're interested in Cognito and DynamoDB and things like that, these are very stable services that are not changing that often. So Cognito and things like that will be the same, so you can learn and follow that guides. Things on the Amplify side is changing quite often, so there might be some differences. But anyway, I'm pretty sure you're gonna learn a lot of new stuff. And welcome to the channel. Make sure to subscribe, guys. If this is the first time you're here, make sure to subscribe to the channel. It really helps us reach more people and help more developers become better mobile developers. So yeah, just takes a couple of seconds, hit the like and subscribe button. I'd really appreciate it. Let's give it a try to see what's going on here. By invoking this function, we already deployed it. And if I do curl this one, no. This curl request. We see okay. Let's look at BrightData logs. That's going to tell us if something happened, like at the logs. 57. It's now, and this is 57. So we see 2 very recent jobs, And if I'm gonna go under, let's say, I don't know, the logs here under edge functions, scrape tracked searches logs, we should see data, an array with two objects where we have data, and here is the snapshot ID. The query iPhone 16, the query MacBook M3, and if we look here, I guess we need to show here not when it was created, but when it was last scraped. So in our components, because I'm pretty sure it worked, I just need to visualize it and show you as well. In the search list item, in the created at, let's do dot updated at a few seconds ago. So we see that the items that were tracked are a few seconds ago, but all of them are a few seconds ago. So most probably this is not updated at, but in the table editor searches, last scraped at. So let's do last scraped at. But if it's not there, or we can even say scraped 2 minutes ago, a month ago, scraped 2 hours ago. But the cool thing is that these that are tracked, they are scraped 2 minutes ago. And if I open it up here, on this page, I also want to do the same. On application search ID, I want to do dot last scraped 3 minutes ago. And while on this page, if I go ahead and invoke that function to start or to scrape the tracked items, we see that it's scraping. Automatically it updated here. And it should, in a second, oh, the iPhone here is done, and we see scraped a few seconds ago. Perfect, and it should already have like price history, which I don't know where it disappeared. Oh, here it is. This item was there for all the searches, and we have a history nicely displayed. Okay, so that means that from our diagram, the edge function that will look through what items should be tracked and will invoke this start scraping job, this function is complete. We can manually invoke it and it's going to automatically do it for all the jobs. And now we simply have to put this CRON in front of it and invoke the function at specific periods of time. For example, every day or every minute or every hour. Based on this job scheduling documentation, we see, I explained it a bit earlier, but let's recap it again. We're gonna do that through two different extensions. One of them is called CRON that allows us to execute jobs at intervals of time. And then, because the job is not something on the database, but the job is to invoke an edge function, we're going to use the pgnet extension to call a function. So let's go and start from CRON. We're going to do that. We're going to have to enable this through the extensions in our home, in our Supabase database extensions. Where is it? Extensions. Let's search for CRON. Let's enable it. And here, select a schema. Do we need? extension. Yeah, let's just do enable extension. So the syntax, the schedule uses the standard CRON syntax, in which star means run every time period and specific numbers means but only at this time. So here it's every minute, every hour for the second one, every day of a month, every month, and this one day of a week, 0 to 6. So this is an example, delete data every week. So cron.schedule, and we are scheduling. This is the name of a job. This is, yeah, okay, every Saturday at 3:30. And this is what it should do. We can call database functions or procedures, but what we're interested in is invoking Supabase edge functions. For this, we need the pg.net as well enabled. So let's go back to our extensions and search for pg.net. It's enabled. And we will make a post request to a Supabase edge function every 30 seconds. Let's try to do that as well. Maybe 30 seconds, it's too... But why is it 30 seconds here? Does it understand that? Can you do like human readable things and not necessarily the syntax of a cron? Or is it an error in the documentation? What do you think? But I'm gonna copy this one from here. Let's move it to a temporary file. It should be... because we need to change some of the stuff. So the name is going to be, or maybe let me actually do this file here. Run scraping cron.sql. And let's adjust this one here. So the name is going to be invoke function. Invoke, let's be very specific not to be confusing. Start scraping. So our function name is going to be scrape tracked searches. Invoke scraper every minute. Let's do every half a minute. I'm just thinking, no, I don't want to risk it. Let's do it every what? 3 minutes. I'm going to go actually and do a cron expression. I'm going to find a tool that will help me. Cron Guru. So every 3 minutes. Minute 3. How to do it? Every 3 minutes. every 10 minutes. Okay, yeah. I needed like every divided by 10, like every 10 minutes. Let's do 3 here and let's copy it in our job like this every 3 minutes. Now what we need to do is using .NET extension, we are gonna send a post request. Here we need to specify the project reference. The project reference, we're gonna get it from Supabase. Project settings. Here is the reference ID. Let's take it. It's going to be here. Supabase.co functions v1. Here is a function name that we want to invoke, and we're going to invoke this one called scrape track searches. Headers, authorization, your anonymous key. Let's remove this one and just add anonymous key here. But anonymous key, will it work with anonymous key? We saw that it's not working, so we need them. We're gonna use the secret key. So from the API service role, let's reveal it, let's copy it, and let's add it here. Body JSON build object time now. I don't think we need a body. Yeah, I don't think we need a body. We don't need to send anything to that function. Request ID. Let's see. Let's copy this select job and let's go in our in our SQL editor and paste this CRON. Just to make sure you see that my tracked searches, if I go here and refresh, were scraped 10 minutes ago. Let's try to execute this SQL that we prepared and do run here. Okay, it has scheduled with this one here. Let's see if anything happens. It's still 10 minutes, but maybe we just need to wait because it's going to run every 3 minutes. So how do we monitor it? Monitoring it, well, we can edit the job, change the frequency of a job with a specific name by running cron.alter. You can specify directly the job ID, for example, 1 in our case, and change the schedule. Alter job, you can do job ID, you can change the schedule, you can send the command database username active. You can call unschedule to unschedule the job. And you can view previously ran jobs. Oh, that's cool. Let's see previously ran jobs by going ahead and executing this select one, run, no rows returned. Probably it didn't run yet. And now if I do it again, we see that it ran the job. If I go to BrightData, we see 2 jobs running, automatically done by this CRON that we set up in our database. And in a second, we should already see new data scraped a few seconds ago, and here we should see new items, new prices. Perfect. So this is going to happen at every 3 minutes. A new job is going to be performed. And as you can see here, if you want to unschedule it, you can run this command in your SQL editor. And here specify the name, and the name we call it invoke scraper every 3 minutes. And that's going to unschedule it. But I'm going to leave it for a bit running to see how it will run every 3 minutes and bring us data. And after some invocations, maybe I'm gonna stop it. So with this cron, we now have this implemented as well. So let's make it green. Now our application becomes even better and better. Oh, thank you very much, Fulbright, for the cron syntax. I bet it is able to understand it. Just like with human readable names, like 3 seconds. Yeah, maybe it is. Postgres is amazing. And I'm gonna leave it here, like this command. It's not needed in the project, but it's for your reference if you're gonna want to run it yourself. Probably I'm going to have to remove this token because you need to use yours. Your Supabase secret token. This here you need to put the ID of your project. So I'm gonna also replace here Supabase project ID. So before you run it, make sure to replace these two and then execute it in the SQL editor. Now I'm gonna do git status, git add, git commit, scraping cron. Oh, I already saw like items appear here automatically. Have you seen it? Because if I will check again, we see another job being performed. And a new scraper. Yeah. Maybe not this one. Something else. Aryan is saying, hello, I'm learning React Native by watching all your projects. I'm learning a lot. Is it enough to become expert in React Native? Well, yeah, with a lot of practice and a lot of projects, like the more you build, the better you're gonna become. You're gonna become better. But there is a certain ceiling that you're gonna hit with YouTube tutorials, and the experience that you're gonna get to go to the next level will probably require you to build extra project, to build project for yourself, and to learn new stuff with every single project that you're building. Try to take an idea of a project that you'd love to build and try to work on it on your free time until you get it to the market, until you get it in the hands of the users, until you, and that experience is going to lead to some challenges, and the challenges are going to allow you to learn new stuff. Another way to master React Native is going to be, like, here is a shameless plug, I'm going to say it, it's the React Native Mastery. This is a course where I put everything that I've learned during the last years as a React Native developer, everything that I've learned by building more than 70 projects with React Native and Expo. I put it here in a very condensed and with the technologies that you need to master everything. So this is a more structured way of learning. It's going to also be project-based, so if you love the style that I'm using on YouTube, you're gonna love it here, but it's going to be way more structured compared to YouTube. Every project is building on top of existing knowledge, so it starts from easy. The first project is quite easy, and it gets into more complicated things like multi-step or local first applications, even into a game. So you're gonna build also like a game. And finally, you're gonna build like one huge social media application and learn more about data fetching, and so on. I'm working on this course. I'm currently finishing the game project, and we're planning to launch it by the end of the year. So if you're interested, make sure to join the waitlist, not to miss when we release it. Okay, I think that it's safe to stop this cron or to update it to run every day. What I would recommend you to do is come back here and update. Maybe don't even put the name here. Let's go ahead, take the name. I mean, first go here to do unschedule in the Supabase and give there the name. Let's run. Unscheduled, true. Now I want to remove every 3 minutes from the name, just do cron, because I want to be flexible on changing how often we call it, like without affecting the name. So let's go ahead and do it every day. So let's do cron every day. That should be, is this every day? This is at 00 and every day. I think this should be the cron for execute this at hour 00 every single day of a month. Execute this one. So we can go ahead and probably do this. And this is the job 2. And what else can we do with this cron thing? I'd like to see. I want to see what are the crons that are running at the moment. PG cron. Get active crons. Delete. I just want to see like a view of what are the currently running crons, just to make sure that I don't leave anything. These are the job run details. Most probably I can do that through the table editor. If I'm gonna go here to cron schema, we have job and job run details. So job here, we should have only the job ID 2. So that's good. The one with ID 0 disappeared. The schedule is this one and the command is this one. So I'm pretty sure that it's correctly stored. Yes, we have a history for old crons, probably. Yes, for the ID 1. But at the moment in the table job, it's only one job that is scheduled. So I'm pretty sure that now everything is okay and we schedule this one only once. And it's going to run and scrape the tracked queries every single day at midnight. Okay, let's do git status. I'm going to do git add git commit -m daily. And let's also do npx Supabase db pool. Oh, we have over 100 people watching at the moment. That's a record in a in the last time. That's awesome. Hello everyone, how are you doing, guys? Let me know if this is the first time you landed on this channel, and shortly introduce yourself. What are you doing and how did you end up here? Are you interested in React Native? Let me know, I'm interested to know about that. And if this is the first time you're watching our channel, because from my analytics I can see that 99% of you guys watching this are not subscribed, let me introduce myself. My name is Vadim, and here at notjust.dev, my goal is to help you learn mobile development, learn React Native Expo by building fun projects. Not by going through documentation or covering the theory, but by actually building real life projects. Today we are actually building a price alert application that is tracking prices on Amazon. We can subscribe to price changes, and whenever a price is going to drop, we're going to be able to notify the user about that. So what we have currently is all the infrastructure for scraping the data, for storing it. It sounds simple from the outside, but there are a couple of things involved, and we have done that during the last 2 live streams. For the data, we are leveraging BrightData with their web scraper API to get the freshest data scraped straight from the Amazon. And we use Supabase as a caching mechanism, and also for the edge functions to do all of the interactions, to store the data in the database, and then using Expo and React Native, we are displaying it here. Now we have these track searches, and the only thing that is left to do is the price alerts and the price history, visualizing it on a chart. So here I'm gonna put chart and price alerts. So for price alerts, what are we going to do? I don't really like the header there. So give me just 1 second. For the layout, I'm going to duplicate this one here and say that in the application product async, let's say product details. So if I go here and then here, we see the title product details. Perfect. Aaron said that he even registered for early access for the course. Did you sign up for the waitlist, or did you actually join when we had that pre-sale? Because in June we had a pre-sale, we had only 50 spots available, and it was sold out like in a couple of hours. Okay, so notifications. What we want to do is to notify the user when we get, for example, here in the finished scraping, if we found a product that has dropped in price, we need to notify the user. How are we gonna notify him? Oh, Zwelitini is saying, I'm a full stack developer, but mostly fond of backend, Java, Spring Boot, and so on. However, I got interested in mobile development, so you were the first to appear on my YouTube. So I follow along. Build free applications. That's so amazing. I'm so happy to hear that. Actually, before going deep into the mobile development, I was also more of a backend developer. I was mostly into Node.js. I was into infrastructure on AWS. At that time, I was the CTO of a startup. So when you are a CTO of a startup, you get to work on the hardest problems, and those usually for us were backend and infrastructure, the AWS, and making sure that our infrastructure scales and is price optimal and so on. So that's what I was spending most of the time. I really enjoy that because you get like these complex challenges. It's fun, it's interesting. But then I really found the love for mobile development. So around 5 years ago, even though I had experience, I was jumping like through back and forth, like back end and front end. When I started on the YouTube, I said like, I'm really curious and I want to dive deeper into mobile development. And still up to this day, we're doing full stack development here on this channel because I believe that's the superpower of a developer. When you can build both the front end and the back end, you have a possibility to build applications yourself. You can build an application in a couple of weeks, deploy it to market, and I think it's really powerful. And that's what I'm trying to do here on this channel. Help you build full stack applications with React Native Expo, tools like Supabase that makes backend easier and faster compared to having to code it yourself. And I hope you enjoy watching the tutorials. And if you do, make sure to subscribe to the channel. So let's think how and when are we going to notify the user? The notifications will definitely will be powered by these product snapshot tables. For example, let's say that we get, I don't know which one will have multiple items, but I'm going to risk it and take this one and say that, hey, we're looking at this item, filter based on async, apply. And this item has a lot of prices. Whenever I'm including a new price, I'm going to look at the previous known price, so probably at this one here, and I'm gonna check if the new price is less than the last known price. In that case, hey, there is a new lower price, and probably it's the moment to notify the user. So this thing is going to happen somewhere when from this edge function we are storing in the database the product snapshots. Now the question is, should we do this logic here in finish scraping, or should we create a new edge function called onNewSnapshot? This edge function is going to be triggered by our database automatically. And let me make them orange. New snapshot inserted. So when database receives a new snapshot, when a new snapshot is inserted in the database, it can automatically trigger an edge function called onNewSnapshot. This edge function will check what was the previous known price for this product, and if it's lower, it's going to send the notification. So if it's lower, it's going to somehow send the notification. I don't know yet how. Send notification. But at least I think this is the right approach to do it. So whenever we get a new snapshot, we invoke an edge function. I'm just thinking if it's not going to be too much. Because let's say we have 10 tracked, even as little as 10 tracked searches. Every search is going to have, like, let's say 10 or, yeah, every time we query the first 10 items. That's going to mean that for 10 searches, we have 10 products, 10 snapshots. That's 100 snapshots there. 100 snapshots inserted in the database and 100 edge function invocations. That's quite a lot. So edge functions. How is the pricing model for Supabase edge functions? Is it per invocation or? Edge functions. So yeah, you have basically it's $2 per 1 million invocations. So it's not that expensive, but still, like, just for 10 searches, tracked searches, you're gonna have 100 invocations. Maybe when search status updated to done, when it's updated to done, maybe then invoke the function, and in this case take all the products, check if, yeah, I think this is a better approach. So we are not edge function, check price, check price drops for all products in a search. Yeah, that's what we're gonna do. We're gonna create an edge function that is going to be called whenever a search has updated. So whenever we finish scraping for one search, we're gonna call an edge function. So in this case, from 100 invocations, when we are working with 10 searches, we go down to only 10 invocations. Now this edge function will receive that search information and will look through all the products in that search if there is new searches that have dropped in price, have lower prices. And if it has, it's going to aggregate them and put it in one single notification, saying that, hey, for the iPhone, these are the 3 products that dropped in price. For example, this one dropped $10, this one $50, but this one $100. So this is a better approach because we send one notification for one search because we're tracking one search. So let's go ahead and start implementing this edge function. And the edge function is going to be called check prices drops for all products in search. Let's do... I'm terrible with names, by the way. Does anyone else have the same problem here? Let me know in the comments. npx Supabase functions new. Let's do search price drops, search. Let's do check search price drops. Okay, I'm happy with this one. It's descriptive. It's check search price drops. Let's open it up, search check price drops here. And this function, we are going to connect automatically from the database. Similar to how we are invoking this function with new things. And I believe in that case, we are going to receive an item called record. Or a better thing to do here is going to be to say, hey, let's destructure everything, request JSON, and let's do a console.log JSON.stringify request JSON null and 2. Basically, whenever you start working, let's see what data we're gonna have to work with. So here, let's go ahead and do npx Supabase functions deploy to deploy the function to production. It's a common developer problem, worse on commit messages. Now that our function is deployed, we can go here and let's, under database, let's use a webhook. Let's create a new webhook that is going to be invoke, how's it called? Check search price drops. Invoke check search price drops on updated search. Very descriptive. Okay, so the condition when to fire the webhook is going to be whenever our public table, public called public searches, update. When we insert a search, we don't have yet items. So only when we update, we're gonna have prices. Let's scroll down and select here edge functions because we want to call the check search price drops. And for the headers, let's put the auth header of the user or my auth header, like the anonymous. Yeah. And I think that's it. Let's do a create webhook. Let's come back here and let's do start scraping. I think our function should be invoked twice because now we are moving the status to scraping and in a second it's going to become done. So if I go to my edge functions, check search price drops, we should already see one invocation. Yes, but this one will have type update record status scraping. So we can discard this one if the status is scraping, we don't have to do anything. We are still waiting. But if the status is going to become done, which is now, and if I will reload, I should see one more log. So if record status, wait, why you're not moving here? So if record status is done, that means that we got new data. So let's do here. Instead of request JSON, I'm going to destructure the record. I'm going to say if record.status is not done, then we can stop and I don't know, I'll return something here. I'll return a simple response. I don't want to think like what response to return. But if it's done, then we have to check price drops. It's also important in this finished scraping, when we save data in the database, I think it's very important the order in which we save information. In the scrape complete, it's important to save product snapshots before we update the search into done, because whenever we update into the done, we want already to have product snapshots there. Okay, now let's go ahead and do some magic. So we know the record, we know the search ID. Here, we're gonna look through for the products in the table editor. We're gonna look for the products. No, we're gonna look through the product search, where search ID is that one. But first we need the Supabase client. So let's go ahead and find the Supabase client from another place. For example, here. Maybe not here, don't like this one. It's basically the same. Supabase client, I don't like the name. Here, Supabase, perfect. Let's take it from here. In our new function, init client, let's initialize the Supabase client. But we also need to make sure to import create client from the Supabase at the top. Sorry for being lazy, for not setting up my environment to properly work with Dino. I thought it should work. Dino land. Maybe I need the extension Dino here. But I have it. I don't know. But we go with it. So here, having the Supabase client and having the search ID, we're gonna first look for the await Supabase dot from. We're gonna look through product searches, because this is the table that connects a product with a search. And we just know the search ID, and we want to get all products for that search. Now we want to select, well, first of all, everything. Where the search ID is equal to record.id, the ID of the search that we received as an update. Select equal. Here we're going to have data and error. But with this query, we're only going to get we're only going to get these items. We're going to get rows with search ID and asins. Based on the asin that we're going to have here, we need to get the actual product information. Or do we? Because maybe we can... Well, yeah, actually we do need to do that. So let's go ahead and do... Yeah, because maybe we're gonna need the name and so on. So we're gonna also select the product. Is it products? It's products. And all the columns from there. Now this data is going to be called product search data. Product search error. Now the product search, I can skip like data from the product search table and only look at the products there. So const products equal product search dot map. And for a product search, I'm only interested in products. Let's put it like this. If there was an error, just to take empty array. So now we have a list of products. And I think that we just need to take the last two prices from the snapshots for that specific product based on the created at time. So the last two prices, that's how we're going to determine if there was a price drop or not. So what is Dino? Good question. Dino is very simple words, is an alternative to Node. Dino, as you can see, Dino, Node. It was created by the same creator from Node, but it fixes some of the old issues of Node. So yeah, basically very similar to Node. Well, some of the differences are noticeable differences are the way we are importing it. So as you can see, there is no Node modules, there is no package.json. We are simply specifying URLs here, and it knows like how to import it. That's major stuff, and it also has a lot of pre-built things that for which we do not need external packages. For example, Dino serves HTTP requests, so we don't need an extra package. Have a look at the documentation, it's pretty powerful. And they recently announced Dino 2, which I didn't have managed to get into that, but that also should be something pretty sweet. But anyway, think about it as Node.js, like a different flavor of Node.js. Back to our prices. So we have products. Let's double check if the products are correct. So JSON stringify products null 2. Let's do deploy. And let's start a scraping job, because that is going to trigger this function. And while we are waiting, let's think about the next steps. As I said, we need to, for every product in this array, we need the last two snapshots, the last two items. So that means that we are going to loop, or we're going to map through the products. And for every product, we need to do something. For every product, we are going to destructure the product data and add here a field called snapshots. And the snapshots you know what? I think I can even get it from the same here, like products, and then inside this parentheses, I think I can get products. Let me try to build this query inside my application. It's going to be faster because I'll get errors right away. For example, if I go to one of the on the search page, so let's go into the application search ID, and let's try to run I'll put a simple button here. Title, test new price drops on press price drops. Let's add this function here. Async. And here in React Native, we also have like TypeScript and so on. So let's start with what we have here. Knowing the ID of a search, this is the ID of a search, we can go ahead and do the same fetch. And let's do console log the error if it was, and then console log. Let's do a JSON stringify version of my product search, null and 2. Now let's look at the data here. Clear. And if I go to one of these, let's clear again. And let's press the button test new price drops. So what do we see? We see an array with asyn and search ID, which is coming from our product search table, asyn and search ID. And because we are querying the products as well, based on this asyn, as you can see, it makes the connection to the details of the asyn. That's cool. That's the data here. Now, based on the asyn from a product, I want to also query the snapshots, product snapshot. To do that, I'm going to say here, hey, products, hey, also query product snapshot warehouse. Yeah. Product snapshot everything. And if I go right now here and clear and do test new price drops again, we see that now every product here has the product snapshot data, which are all the data there. I'm wondering if I can filter or sort them there, but I think I cannot. That's the problem, but maybe we can work with that as well. Supabase query related tables. So we can do this. Limit query filter with relationship table to filter with relationship table. Range category inner. Yeah, I think I will go with it. Even if we have all of them, what I will do next is let's loop for product search. Const price drops. Or maybe I can select product snapshots. Read rows. Yeah, I'd really love to do it on a database layer, like to only get the last two snapshots. To do it on the database layer, like not here. So what I would have to do is I'd have to do product search dot products. Here, products dot map. If it's null, come on, return. Come on, it exists. So for every product, I want to do a Supabase query from product snapshot, select everything where the column asyn is equal to product.asyn, and I want to order by the column final price, not final price. I want to look at the last two. So I will order by created at. Here ascending should be false. I want to only look at the last two. So first I order, then I do limit two items, the last two prices. Now the Supabase. Let's put this one into a function get product last prices is going to receive a product async is going to do this query. It's going to take data and error await, and it's going to return the product plus snapshots is going to be data. So let's go ahead and take this function and say that, hey, for every product I want to do this function, and then I'll put it into products equal to await promise.all. So I will, for every product, I'm gonna fetch like their last two prices, and then I'm gonna wait for them and get this information here. So let's now try to render this one. So if I go here to iPhone and then test new price drops, we see possible unhandled rejection. That's because what? Let's see console log error. Test new price drops. Test. If I look here, cannot read property map of undefined. Cannot read property map, which is here, map, because product search dot products. Let's console log to see what it is. Product search. Test new price. Product search. Oh yeah, product search is actually the array. So I need to do product search map, and then we need to do ps.products. Okay, now if I do this, test price drops, we have a lot of null. I don't know where from, but at least we have snapshots with last two prices. This one was 1618, 1612. So this one is the latest, and this one is a bit earlier. So we can now loop through these products. Console and say that, hey, price drops. Guys, I need really quick to the toilet, and I come back and we finish this function for calculating the price drops. Give me just 1 second. So how do we calculate price drops? We're gonna look through this array and find the product that has this snapshot lower than this one. So let's do price drops is going to equal to products dot filter. We're gonna look for them and we're gonna look for the product that has a price drop. So if first of all, to have a price drop, we should have two items in the snapshots, because if it's the first time, for example, here, snapshots has only one item, so it cannot have a price drop here. So filter the ones that have the snapshots length equal or more than 2 or equal to 2. And if the snapshot at position 0, which is the most recent one, 57, dot final price is less than the previous one, then that product has a price drop. So we can go ahead and only show the price drops. If I go ahead and go here, test new prices, we should see, I have a lot of console logs. I'll remove this one. I'll remove this one. Yeah. Price drops. So it's empty. But I will also, let's also track the new items. So items that appeared in the search. So new items, new products. So we're going to look at them by looking if the snapshots does not have a length of 2, that means that's a new product. Or if it has lower or equal than 1, that's a new product. So let's do a console log. New products as well. Because maybe there is something new that appears that you might be interested. Drops. Now if I clear and do test, we're gonna see the drops are nothing, but there are some new items here. Not a lot, but there are. Or actually, this might be also old, old items that are not present in the new fetches. So we need to also check when it was fetched. Everything started with, here we're gonna have information about, yeah, let's hold a little bit on the new products and only do price drops. I'm gonna go into the database and manually say that, hey, this 153 price was more, it was 656. I'm gonna reload, and I don't know if it's part of this one or not, but let's try test drops, and we see, hey, there is a price drop for this item for the iPhone that was 656 and now it's 316. Awesome. So we found a price drop. Now it's a matter of using this information to send it somewhere. But let me take it, let me take it to the zoo. Let me take this one from here and move it back to our edge function, because that's where the functionality should happen. Supabase, check, search, price drops. And here I'm going to remove and paste it like this. And instead of ID is going to be record.id. So yeah, here you're gonna do like if price drops dot length is more than 0, you need to notify the user. And the message, you're gonna create it like this somehow, like I don't know, message is equal to, let's say, there are, let's do price drops dot length, 1 or 2 price drops in your search. Or we found X amount products. No, I think there are in your search. Then you can go ahead and say, let's loop through price drops dot map, and for every product I'm going to say the following string. I don't know, let's say we are going to display product dot name product.name you're definitely gonna want to show the product.url and the old price and the new price. So product.snapshots in position 1 is the old price dot final price from this amount dropped to this amount, to the first snapshot, the latest one. Let's see if we are correctly creating this message by copying in our front end by doing here message price drops length. Let's do console.log message test. There are one price drop in your search, Apple, iPhone, and so on, the URL from 656 to 616. Perfect, that's exactly what I want. Probably I need one more $sign here. And product name, product URL from 2, and maybe at the end we're gonna put like some divider. And this is going to be the message that you would want to send to the user. I don't even need this console log because I'm only going to look at the price drop. Let's try to see it in practice. Git by doing npx Supabase functions deploy. And now by scraping it again. So we see that it started scraping. When it finishes, it's going to invoke our, it's going to store data in the database. It's going to update the search status, and when that happens, automatically we're going to invoke this edge function that will check if there are any price drops and will create the message that later we can send as a notification. So let's check on BrightData. The status is ready. That means that we have new items here. Probably, yeah, right now there won't be any price drops because, yeah, let me double check that. If I do price drops logs, there should be 0. Get product class prices. I forgot to move this function, get product class prices. This function should be moved here. It can be at the top before serve, right? No, it actually, because it needs Supabase. So I will put it inside here. Let's try to redeploy because I forgot a piece of code there. But what we need to do on the database or on table editor under product snapshots, I'm filtering for one specific product and I'm going to go ahead and manually increase the price to 720. But make sure to update the last one because now we're going to fetch a new price and we need to make sure that it looks like a price drop. So previously it was 720. Now after we have deployed and started a new scrape job, scraping, this is done. That means that we can go safely. You see the last one is a price drop. And if we go into the edge functions, price drops, logs, we should see there are 2 price drops in your search. Cool, there are actually 2 of them? How? The first one is the one from 720 to 616. But look, there is one that I didn't do anything and it's actually, we found a price drop. It's not a simulated one, it's an actual price drop. So if I copy this URL, while we've been playing with our tracker, we already found a price drop. It cannot ship to my address, I need to change it, but this product was 982, now it's 978. And we can check that by looking at, let me find the ASIN of this product. How to find the ASIN? I just want to look in the database to see the history. If I look at the network, will I find here the ASIN of this item? Chill. I need fetch. No, it's too much. But maybe I can find it by the look of it. Apple 15 Pro Max. Apple 15, Apple 15, Apple 15, no, Apple 15, Apple, where is it? Pro Max, but not this one, not this color. Apple 15 Pro Max 200, natural titanium. I think this one. 78, was that the price? The dropped price? 78, let's open this one. And look, we were tracking it. So, October 4th. Yeah, it was changed to 989 and then 982. I don't remember us doing this. So I'm pretty impressed. And I'm confused, like if it's an actual price drop that we found out here, or if I changed it in the database and I forgot about it. But I don't remember changing it, and I would never change it with 95. So yeah, in fact, this is a price drop that we found by building this application. Oh my God. So yeah, we found this, we created this message. Now it's just a matter of sending this message to the user, either through email or through the notifications. For emailing, Supabase integrates well with resend.com, so you can send an email to the user based on the new price drops. I'm not going to cover that in this video because we are running out of time, but we have implemented everything in the system to have this as a scalable solution so that you can take it from here and build your application with it. I really hope you enjoy this project, guys. Thank you very much, BrightData, for making it possible, for sponsoring this tutorial. I had a ton of fun preparing it and building it live here with you. And if you build something like this, make sure to let me know what is the result, what are the challenges, and if you actually find some nice deals with it. All right, I'll see you next time and have a nice week. Bye-bye.